Well, what was interesting when we went into Create Telecom is I walked in and we started having this conversation about what kind of cloud they needed, and they said, we need a 5.9 cloud. And I said, you need a 5.9 cloud? Okay, I can build that. Do you know how expensive that's going to be? Well, we have apps that require 5.9s. And I said, okay, great. Tell me about an application that you have that requires 5.9s. Well, our billing system. We're a carrier that can never be down. We need a 5.9 infrastructure to put underneath it. I said, great. What was the uptime of your billing system last year? 3 nines. Year before, 3 nines. Year before, 3 nines. I said, well, we can put a 5.9 infrastructure underneath that, but it's still going to be a 3.9 app. And the reality is that the complexity is shifting out of the infrastructure into the application. But if we want 3, 4, 5.9 applications, that's the only place it can go. That's the only place it can go. This is the hardest problem that I have trying to communicate to existing enterprise folks. They're used to trying to take this risk mitigation approach where it's like, you know, if we just throw everything in the kitchen sink at it, we gold plate like all the hardware, we have, you know, triple redundancy on everything, you know, it'll never go down. And the reality is
until
that
somebody hits the EPO.
Yeah, and then it still happens. And the thing is that when you shift the responsibility to the app layer, it does become more complex, but it means that you can do a lot more. You can do, you know, dual transactions across 2 data centers that are, you know, 2,500 miles apart, and the latency doesn't matter because you're figuring out how to do those transactions in a way that works for your business. But you know, that shift is actually important, and it's fundamental to our success. And if we want to move to a world where we have all these online services that have very high uptimes, we have to accept it.
Yeah, I think one of the biggest challenges today, if you look at public cloud architectures, there are, like Netflix is a classic example. They say, look, we architect around Amazon's weaknesses. Great. Then you look at companies that say, we're going to go deploy private cloud on-premise. And the reality is that the benefits of cloud mean outsource infrastructure, they mean outsource operations of that infrastructure, and you're really using the services that are available on top. Well, the IT teams that are used to running VMware or running things on-premise don't necessarily know how to deal with the failure scenarios that exist within a private cloud itself. So Amazon, you get the application architecture to talk and to survive against those failure scenarios. Yet on private cloud, you have an environment where the failure scenario could be the entire cloud in itself. So I think we've got this interesting challenge of duality of environment, and people tend to say, look, I want private cloud because it exists. I'm used to it, right? I can put it on my hardware, I can touch it, I can have Bob, the VM server, sit there, and I can fix it when it breaks. But the scope of failure has increased so much more dramatically with that type of deployment that people, it just boggles their mind when they think about how to solve these things. And I think this is one of the challenges we've experienced today with particularly with OpenStack, as we talk about people adopting the technology and then giving up because it was too hard. It's because the way OpenStack has been delivered today requires such a level of expertise inside of an organization that things break and they just give up on it. As kind of as Randy was saying, look, we need it to be up all the time. Well, you need the experience on how to run these things. You need the technology to be distributed and delivered with not just support, but with that actual operational capability, and we've just been approaching it. The industry's been approaching it all wrong to date. Public cloud's got it figured out, but the private cloud marketplace, which really gives that enterprise the power, again, because of that proximity, has had it all wrong for the last couple of years.
Do you remember the giant AWS downtime a couple, 2-3 years back?
Which one? There were 2 of them.
Was it the multi-day, like the biggest
They had
of
the
them
EBS control plane flood,
Yeah.
and then they had a second EBS failure due to
the
power
ELB one
outage,
on
lightning
New Year's
strike.
Eve or Christmas
The
Eve.
first
That was
one where it
the
first came
second
out,
one.
that people were just spinning through instances and it sort of cascaded worse.
Yeah, that was
Yeah.
the EBS control plane
Yeah, that one.
overflow.
One of our advertising clients was up the whole time due to multi-zone.
Netflix was up the whole
yeah,
time.
exactly. It is
Except for New
possible.
Year's, Christmas Eve.
Yeah, that one they didn't
It
do
is
well.
possible to stay up
That was
through
their fault.
those. On the other hand, you remember when the Media Temple building lost power? They had the cascading failure, all the redundant backups in the world. They lost power. The backup generator kicked in, put too much strain on the backup generator, which kicked out. And everyone in the Media Temple building lost all of their web for I don't remember how long. You are approaching a point where public cloud might have its problems, but if you build right for it, is going to be better uptime than you're going to get on your private hosting. And unless you are very competent at what you're doing, you have multiple data centers that can rival Amazon, and that you can build systems that on public cloud or more robust if you handle this. So at the end of the day, it comes down to why do you really need private cloud? Unless if you're scared of this complexity, maybe you shouldn't be building and maintaining a private cloud. If you don't have the distributed systems team on hand to debug these sort of hard problems, is public cloud such a bad thing?
I don't see these things as separate
Yeah, I
things,
don't
actually.
agree.
I mean, in my experience, everybody's looking at hybrid cloud. They're not looking at private and public. They're looking at both.
Multi-cloud.
Fine, call it what you like. I don't care. And the reason is that, one, distribution of risk, but two, it goes back to my definition of cloud, which has nothing to do with outsourcing. My definition of cloud is that cloud computing is a new form of IT that's coming from the web scale guys. If you go and you look at what Microsoft and Amazon and Google all do in their data centers, from the concrete through the applications themselves, it is fundamentally different than anything that's been done in enterprise data centers ever before. At the same time, all the patterns they're using are highly overlapping. If you drew a Venn diagram, you'd almost have a circle, right? So that's cloud computing. It's this new way of doing computing that displaces what I think of as enterprise computing or client server in the same way that displaced mainframe. And so the example I like to give is Hadoop. I fit big data and DevOps inside of cloud. That's me. When you think about Hadoop, what is Hadoop? It's Google's MapReduce. Except it's not just Google's MapReduce. It's Google's MapReduce plus Google's reference architecture. It says use commodity hardware, use commodity rack mount servers connected with a reasonably high-speed switch fabric, use a JBOD with no RAID, and scale it out and use Linux. Now, if you went back 10 years and you told companies they'd be doing business intelligence on top of a scaled-out Linux system using commodity components and no redundancy at the data layer, they would go, "You're crazy." But yet, it's taken off in a huge way. It's because those techniques are bleeding down into the mainstream now. So you don't have a private cloud if you've got a VMware system. You don't have a private cloud unless you've built a private cloud that looks like Amazon Web Services, that brings the same kinds of cost efficiencies, that has the same guarantees around VM uptime, 2.5 nines. And unless you're writing your cloud native applications on top of it and getting the 3, 4, 5 nines by doing that. And if you're doing all that, you should, of course, be taking those applications and building them in a deployable framework that allows you to do repeatability both on your private cloud and your public cloud and move those applications back and forth as needed.
I also think some of the complexity is misstated in that every computing system is distributed, and before the cloud, people pretended they weren't. They pretended, oh, we're not building we're not building distributed systems. We're just doing simple database replication. Sorry, simple database replication is a distributed system, and it had the same problems. Now that we have more latency, we start seeing the real problems that we were ignoring before. And if you're not building your apps right, you're not building your apps right anyways. And you were just covering it for the fact that you're like, oh, we have a second latency between the database. That's good enough. That's still not correct in a distributed system sense. And now when you're talking about cross-country and the cloud, you actually have to build these sort of assumptions of how do you address these failure states right in your app in the first place. So I think some of the complexity is a little misstated in that it's just making you more aware of it by nature of the cloud itself.